Hello viewers, this is Mithul here. In this module, I'll be covering about module number 4.3, which is type of indexes, in which we will be covering about the clustered index, non-clustered index, filter index, covered index, column store index, index maintenance strategies. All of this is what we'll be covering in this. So let's get started. Alright, so first of all, we'll be learning about the heap without index, like table without any index, means there is no index on a table, which is what we'll be learning first. So what are the features of that kind of a table, right? In which the table is called a heap, which has a pointer that contains the following, and is known as row ID. Now, when you say pointer that contains following, means pointer contains what? Pointer contains file identifier, page number, and number of row on the page. All three of these is contained within the pointer, and that pointer is called or known as row ID. Okay. So in the case of heap, it is storing or it is known as row ID, that pointer. Okay. Second point is table data is not stored in a specific order of pages. Instead, it is stored in a random order in multiple pages. Okay. The third point is data retrieval is slow. If the data is randomly stored in any of the pages, right, randomly, so like while retrieving also it has to go to a particular page and then read that content, right? So retrieving, suppose say like if one record itself is saved in, or say like multiple record is saved for a particular table is saved on a different pages, right? So retrieval itself will become slow, because finding each and every content from multiple pages and presenting it in the output will take time, right? So that is why it is the slowness. There is a slowness. Now, how it is stored in the in the physical file, right? The storage structure wise. So storage structure wise, heaps are stored as if like on the root node of the heap, it contains the index page. Okay. Then the data pages, which will contain the table data, meaning whatever there may be the data, like the exact data will be located in the data pages. Then the leaf node contains the row ID, how I just told you, right? Like it will have the file identifier, then the page number, and the number of row for that particular page. Okay, so that is how it is saved in the leaf node. Now let us just see how the kind of table can be created. We will use the same learning DB as we've been using. So yeah, let's just drop the table. In case if there is any table called branch, then we will just refresh and see like if there is any. No, there isn't any, but still we will run as per our process. So it will make sure like, yeah, there isn't any duplicate existing. Now we will create the table without any indexes. So without any indexes means there is no primary key, right? There is no foreign, there is no unique constraint. So both of these will go and create the indexes on the table, right? For that sake, there are no indexes on this table. So let us just create this table first, because all of these columns are very unique, like batch ID, course ID, student ID. Course ID will refer to the course table, which is our stage.course table, and student ID we will refer for the stage.student. Okay, so there will be relationship that we will establish between the batch table and the student batch table and the course table. So how we can establish the relation, we learned in the previous session, right? So how it can be done is using the reference key. Using the reference key means foreign key. So the foreign keys are established within the same creation of the table with using the constraint. So constraint name, constraint type, column name, then references, and then the table name using the column name. Okay, so that is how we will be doing the constraint for the foreign key. So let's just create the table. Okay, so we've got the table created now. Let's just refresh it and see like if it is created. Yes, it is created. We will see that all the columns are created, foreign keys are created, right? So those of the foreign keys are also present under the keys section here. Okay, and now we will double check there is no indexes, right? Because it's like a heap kind of structure. So we will move on further. Now the second kind of that is the type of table which will have an index on it. So the index, if the table has an index of clustered index, right? So what are the features for that? Index, clustered index can only be one at for a particular table. It can never be more than one. Okay, the clustered index always be one for a particular table. Now for that clustered index, how many columns can be there? So there are maximum 16 columns as a composite key you can use to create this clustered index. Okay, so let's say the second point, data is stored in the logical order for pages within the table. Means it is logically stored in a right order for the pages within the table, or data within each page for clustered index key. Okay, so basically just understand that everything is sorted and in order, saved with an assigned clustered index key to it. Okay, in the case of clustered index, so that the retrieval will be faster, because now as it is stored and located and assigned sequence wise like the indexing keys, so it will be rightly in the order saved on a particular page. So the data retrieval will be easy, because if you just go to a particular page, the entire record would come up from that point, right? For that sake. Then the storage structure, how the storage structure is formed for that. So for the root node contains the index pages. Then the data pages contains the table data. Okay, now leaf nodes contains the clustered index key. In the previous case we see that it was like a row ID, whereas in this case we will be having clustered index key for the clustered index, right? So that is what it will have. Now we will just drop in case if there is any clustered index created on the batch table, which is not at present currently we see, right? Because there is no primary key declared or defined for it, so there is no clustered index on it. So let us just drop exist, right? So it ran successfully, and now we will create the clustered index batch ID for the table batch table, and the column will be batch ID. We are making that column as a clustered index. Okay, so let's just say clustered index created, and we will be doing the refresh of this column section here, right? So it is the clustered index is created on the batch ID column, right? Now the third type, the second type ideally, like the before the first one was just heap, then we learned about the clustered index as the first type, because heap I am not considering as a type. By default the table is of heap kind. So starting with the index type as clustered index, then second type is non-clustered. Okay, so that is what we'll be understanding now. So non-clustered index, how it is created and what are the features for that. Non-clustered index, always there is a rule that after you create the clustered index, only and only after that we should be creating the non-clustered index. Why? Because the clustered index has a non-clustered index has a reference of clustered index keys. For that reason, every time we are creating this non-clustered index, we should make sure that the clustered index is already created. In case you create the clustered index after the non-clustered index, the creation of the clustered index itself will take some time, because it has to sync up again all of this non-clustered index thing, right? Because all of this non-clustered index is referring to the clustering key of the clustered index, right? For that reason, it has to be revised again for that purpose. So just make sure always create the clustered index first and then create the non-clustered for a table. Okay, more than one indexes, the non-clustered indexes can be created. Second point is leaf level refers to the base table structure, not data. Okay, it just refers to the table structure, not the data. Sorry. Then the third point is we can use the include clause to combine the more keys. Now, what does this mean? Include will come in the subsequent part after this. We are learning about the second kind. The third kind will be the filtered, and the fourth kind will be the covering index, in which we will learn about this include. But for now, just understand that include is a keyword. Why we use it? Include is used in the covering index. So for that purpose also, it may add up all those keys together with this non-clustered key, right? So the data retrieval will be quicker for repeated queries on the column of a table. So if you want to retrieve the data quicker, then non-clustered index is also the best bet, right? You can always go for it. Storage structure wise, the root node is index page. Leaf node here in this case comes on the second stage. Earlier it was on the last. Now leaf node contains the clustered index key here. You see what was contained in the clustered index? It was containing clustered index keys itself. Now in the non-clustered index also it is referring to the clustered index key. Why? Because it is relying on the clustered index keys to read and to go to that particular row of the data. Meaning it's a pointer, you can say, in that sense. Okay, it's a pointer to a data using the clustered index. So that will take you to the particular row of the index, and then you can read the data together in the data page from the data pages. Okay, so that is how the non-clustered index works. So let's just drop and create the non-clustered index on the batch, the table as stage.batch, and the column will be start date on which we are creating the non-clustered index. Okay, all right, so it's created. Now we will go and refresh the stage.batch table and see like if the required indexes are created or not, right? So first of all, we created the clustered index, which was the batch ID, which is created right in here. This ID, this IX batch ID, right? That is what the clustered index is. The second one we just got created is batch underscore start date. This is the non-clustered, non-unique index, right? So two of these are created. Now let us understand about the filtered index. What is filtered index? The definition of the filtered index is the filtered index is an optimized disk based row store non-clustered index, especially suited to cover queries that select from a well-defined subset of a data. Okay. Now features of the filtered data: improves query performance and plan quality. The second point is reduce index maintenance cost, and the third point is reduces index storage cost. Why? Because we are filtering the index, because the index, whatever the index that you are creating, right, you are filtering some sort of because by nature index itself saves each and every row of the table. Now if you apply the filter on a particular table, then what will happen? It will shorten, or say it will lessen the number of rows from a table and keep only selected number of rows in that index, right? For that reason it will occupy less storage, right? For that reason it is saying like storage cost is less. So let us just run that as well. Now seeing to the syntax, create non-clustered index, then the index name on tables on the schema, table name stage dot batch, and then the column name is start date, where end date means there is an end date column, right? In the batch table there is a column called end date. That column currently is nullable. What we are interested to filter for this index is it should filter only the records, or it should create an index only on the records where end date is not null, right? So let us just run and create it, right? Okay, so now the filtered index also is created on it, and we will refresh and see the third index also created for the end date, right? This is called filtered index here, right? You can see them, filtered index keyword, right? This is the third index we just created. Now let us understand about the fourth type of the index, which is the covering index. Okay, now fourth kind is covering index. What it will do, it will include the columns in the non-clustered index. So by definition, by including the non-key columns, when you say non-key columns means non-primary key columns, you can create non-clustered indexes that cover more queries, right? So the benefit of it is like they are not considered by the database engine when calculating the number of index key columns, because it is covered under a particular index only. So they are not separately considered as a separate index. So it may not occupy additional size while creating the index on it, right? So that it is saying like it may not occupy additional size and it may not be considered, right? So let's just run and see. Now let's just see the syntax of it. Create non-clustered index, index name on the schema name dot table name, and then the column name. Include is the keyword that you will add here, and in the parenthesis you would add all of those columns on which you would like to create the covering index. Covering index meaning like primarily you are creating the non-clustered index on the student ID, but in addition to that you would like 3 more columns to be added in the same index, so that all 4 of them can be created as a single non-clustered index, right? There won't be any separate indexes created for that. So it may occupy less storage, right? For that reason. So let us just create it. Okay, so it ran successfully. We will go here in the index branch and then do the refresh. So the fourth number index also is created, and what is that, what's the name to that is this one, right? The batch student ID, that is what the given name to it, right? And in here if you right click and you see the properties, here you see by default you see the column called student ID, which is the primary column on which the index is created, right? But the interesting thing is included columns. How many columns are included here? Start date, end date, and grade. All 3 of these columns are also included in this index itself, right? If you want to modify it visually, then you can add, remove all of those that you can do from this screen. Okay, you select that particular entry and then do remove, move up, them, down, or right, that you can do from here. So that is the thing. And the storage primarily file group, right? And yeah, that is the thing. Filter index or filter expression, if you had any, then it will be applied, and if there is any fragmentation you may be able to see the fragmentation, how much fragmentation is there for the particular page, and the total fragmentation percentage, whatever it may be there, it will show up here in this tab. Okay, so anytime you want to see for any kind of index, then go to that index and right click on it. You may see that there will be some percentage that you may see after a period of time when you have the data within the table and there is frequent DML operation applied on that table, because right now we do not have the data since we are just learning and we just started creating the tables, so we do not have the data. But later part, once we will have that, then I can give you the example of it. Okay, so for now, just for this information, that is the thing. All right, let's go back to the SSMS and then learn about the fifth thing. Now fifth kind of, or say like a fourth we understood about the covering index. The fifth kind of index is column store index. Now what is column store index, which is a new type of index added to the SQL Server. Okay, what is the purpose of this column store index? It is a technology for storing, retrieving and managing the data by using a columnar data format. Now columnar data format means what? It is called a column store, but how it is stored, how it is different than the regular indexes, what we just learned, right? The clustered index and non-clustered index, how it is different than those indexes. So both of those indexes that we learned, that was applied as if like a row store index. It could be called as row store kind of a layout. Now it is a little bit by the term it is little bit confusing to you, but traditionally it was stored as stored the data in a table. The data was stored in a table, right? So how this row store works is, row store is a data that is logically organized as a table with rows and columns and physically stored in a row wise data format. Okay, so it is stored as if like a single row in a physical structure of the index. In the index file it will be stored as if like a row. Okay, just understand that way. And in the case of column store, how it is stored, now we will understand. A column store is a data that is logically organized as a table, same as the row store, meaning like the old way of the columns, the clustered index and non-clustered index is up to here, and then physically stored in a column wise data format. Earlier it was row wise data format, whereas now it will be saved as a column wise data format. So that is how it is different in a storage structure wise. Now what is row group here? A row group is a group of rows that are compressed into column store format at the same time. Okay, now what is row group? It's a row group is a group of rows that are compressed into column store format. Column store format is what? Meaning like when it is saved as if like column wise data, right? The data is saved in the index as if column wise. So it is saved in that format. At the same time, a row group usually contains the maximum number of rows per row group, which is 1048576 rows, right? At the same time, it can for a particular row group it can occupy this many rows within that, right? Now what is column segment? All of these terms are like all of these terms are used in a way in the definition or in understanding the column store. For that I am just explaining all these terms, what all these terms are, right? So if you hear them, like, you may not find it unknown or unheard, right, for that thing. So let's see what is column segment. A column segment is a column of data from within the row group, as we just learned the row group, right? So after the row group we are learning what is column segment. Column segment is a column of data from within the row group. Contains one column segment for every column in the table. One column segment for every column in the table. So it is saving the data for all the columns of a table. Consider, say, like there are 5 columns. Now all 5 columns it is fetching and it is saving in a one segment. Means it is considered as a single segment. Means all of the data from the 5 columns are stored in a column wide format, not like a row wide format, right? In a columnar format it will be saved in a index. That is how the segment is made up. Okay, so the second point says there is metadata with each segment to allow for fast elimination of segments without reading them. Okay, so all of these points are very important that we need to understand. So I'm going through it now. What are the features of the column store index? It resides in the memory, first thing, as compressed data in pages based on columns instead of rows. So the data is saved in the form of columns instead of rows. So it resides in the memory and it is saved in a compressed format. So it saves the memory and occupies less storage space. Now second point is mostly used for data warehouse, star or snowflake schemas with high volume of data. So generally we will use that column store index in the data warehousing for the star schema or snowflake schemas with high volume of data. Okay. The third point is can compress the data and help retrieve data more quicker than the clustered index, row based data store, analytics, query processing, right? Now the types within the column store also there are two types. What is that? First one is clustered column store, like we earlier understood, like clustered column, clustered index and non-clustered index. Now there is a the fifth type that we are learning, which is clustered column store index, right? I mean the column store index, and in which the type is clustered column store. Okay, now clustered column store is applied on what? Clustered index, we learned that clustered index will be created for a particular column for a particular column, right? Whereas here the clustered column store, how it is created, it covers all the columns of a table. That is the difference. Okay, see, that was for a particular column or say composite key itself, maybe like made up of 16 up to 16 columns, whereas here in this case it will be made up of all the columns of a table, not just 2 or 3 which are made like primary key. It is covering all of the column of a table, right? That is why this is much better than that. Now only one, like clustered index also was created for a table, like one in clustered index. Since it is like the clustered column store itself is created for all the column of a table, then there is nothing left on it, right? So we can say like it can only be one at the same time. There is nothing else we can create because there is nothing which is left on which we need to create this again, right? So for that reason there is only one index which is clustered column store for the entire table. Okay, and it can be updated. Whereas the second type in that is non-clustered column store. It covers the sum or all of the columns of the table. And second is can be combined with more indexes. It cannot be updated and is read only. Okay. Now usage wise, what are the usages of it, right? In the data warehousing, suppose if you are using this table, right? This index, because we are mainly using this for the data warehousing purpose. So I'm just showing you the kind of structure of a table, various kind of structure in the data warehousing, right? How dimensional modeling is using. So first of all we land the data into the staging table, right? So that's where like the stage table prefer to use non-clustered index on a table. Okay. And in the case of dimension table, after we move the data, we fine tune the data, we move the data from stage tables to the dimension tables. So the dimension will save like the preferred to use clustered index. Here it is not using the non-clustered because it is using the clustered index on the surrogate key for each one. Now, what is surrogate key? Surrogate key is an identity column kind of thing. Okay, so in which like it keeps on increment by 1, right? Like we have seen earlier while creating the tables, how we created it, identity 1 comma 1. That is what we identify as surrogate key. Okay. So, okay, let me go to that point where we were. Yeah, so surrogate key for each one. Now also consider the non-clustered index for business keys. So then we have to consider the non-clustered index for the business keys or frequently accessed columns. Avoid partitioning on this. Okay, so in the dimension tables. Then the fact tables, what we need to do is prefer to use clustered index on the date key. Okay, in the fact tables there will be primary key and there will be foreign key to the dimension tables, right? So in that case we will be using the date keys as a clustered index, then non-clustered key for the foreign keys, right? Non-clustered index for the foreign keys, and possibly use the column store for that. I mean, in the case of the primary key while you create for the fact table, right? So that, and for periodic or snapshot fact, use cluster key or cluster key on the date key. Okay, for periodic meaning like the date dimension will have the periodic data, right? And for the snapshot kind of fact, periodic or snapshot kind of fact tables, we should use the cluster key on the date key. Okay, that is how we should be using this index. Now the benefits to that. What is the benefit? It can improve the efficiency of the table 6 in a data warehouse. We can create a non-clustered index designed to run queries that perform based with table 6. It won't require a full scan of the column store index and return the correct results faster by doing a binary search through a B tree, meaning binary search tree index, right? That is the main advantage. The data can be retrieved faster and it consumes less space in the the storage size. So first of all, we will try to understand what we are creating here is a table with a clustered column store index can have one or more unique constraint with non-clustered index on it. Okay. Now what we will do, first of all, we will create the clustered column store index on the table itself, the entire table, and then we will apply a unique constraint. When you apply, by default unique constraint considers or creates the non-clustered index. That is what we are learning here. So we are creating the column store. So let us just drop the table, like I'm creating the dimension customer under the DWS schema. So if there is any, it will remove it, and then we will create the table called dimension customer. See, dimension customer always, like the dimensions, will contain the descriptive data. Okay, it may never have the calculation related, or there is no measure related fields, right? So all of these fields are of descriptive kind of columns. So that is why we are creating a dimension customer here. Okay, so let's just run this create table. So dimension is created. Now what we are doing is we are creating the column store index on top of it. So what is the syntax for that? Simple, like the clustered index, only just add the keyword in between the clustered index as column store. Difference here is to remember is, like here the index name is fine, but on the table, on a particular table you are applying this, right? Here that index is what you are applying on that table entirely. So that, and there is no column here, you see. In the case of clustered index, when we applied, there was a column for that, right? Where is the clustered? Yeah. So in the case when you applied the clustered index, you applied on batch ID column, right? Create clustered index name, on table schema name dot table name and then the column name, right? But here in the case of column store, we do not need a column name here. Okay, instead it is just simple the table name, because we are applying the index on the entire table here. Store the table as a clustered column store index. Okay, so we are creating it now. Okay, it is created. Now create a unique non-clustered index on it. So we will be create unique index, then the index name as this, and on the schema name dot table name, in the parenthesis you will write the column name of the dimension, right, on which you want to create the unique index, right? So we will create this unique index as well. So it is also created. Now there is a second kind on in that. Okay, what is that? When a table with a clustered column store index cannot have a primary key constraint with clustered index. Let me read it again for us. A table with a clustered column store index cannot have a primary key constraint with clustered index. Why? Because primary key cannot be applied on the entire row, first thing, because primary key has a certain limitation, right? Primary key has maximum limit of 16 columns that can be covered in a index, right? For that sake, so we cannot create that. And why? The second reason why is to create the primary key constraint on a clustered column store table, you must declare the primary key as non-clustered index here in the case of column store index only. Okay, so first of all you need to create the index, meaning like the clustered column store index on the entire table, and then only you will apply the non-clustered index on the particular primary key column. Okay, so either way you can do it, whether you want to apply the primary key with non-clustered index on a particular column, well, before you create a table, then you create the table and you apply the constraint called constraint name primary key non-clustered index. See, usually primary key has the clustered index applied to it. Here we are applying the non-clustered index on it. This is the reason we are doing that way. Okay, so because in the column store it may not work the way how it earlier works, right? In the row store how it works, right, earlier. So in the column store it works the different way. For that reason we will have to first of all let's just drop the table if there is anything created for that, and then again we will create this table with a constraint for the constraint name, and then the constraint type primary key, and the non-clustered kind of index that we are creating, and the column name is customer key. So primary key using the non-clustered index. Okay, so that is what we are creating first. Let's just create. So it is created, and then we are using, or we are applying, now we will convert the table to the column store index. Okay, so first of all what we did, we applied the non-clustered index on a particular column, and then we are applying the column store, the clustered column store on top of it, so that what will happen is any non-clustered indexes that you want to apply on this table, right, that you need to apply well before you create the table as column store index. And mainly for the primary key it is mandatory. Okay, unique index still you can create after you create the column store indexes, but in the case of primary key you should better create it well before you create the clustered column store index on a particular table. Okay, all right, so let's just run if it was not run once again. Okay, everything ran successfully. So now we should be seeing the tables called table called dimension dim customer, and in which the column store index should also be there, right? Yeah, so see, column store index, clustered column store, and the non-clustered unique index also is created on it, right? So the column wise also we can see customer key is the primary key now. Okay. So yeah, so that is created now, and now we are learning about the maintenance, how to maintain the indexes in the SQL Server, right? Now there is a first type to maintain the indexes is, once the indexes are applied for a table, say like it applies when user multiple time user does some DML operations. Okay, over a period of time user removes some data, user adds some data, right? So all of these operations are performed on a particular table. So what may happen is, the wherever the data is saved in the index pages, right, that may find the fragmentation, right? How we save the data in a physical disk also, sometimes you add some file to a disk and you remove the file from a disk, right? So what may happen is, it has allocated some space to a particular file, right, in the form of bits and all of those. But now as you removed it, some of the fragmentation will happen because of that file storage. It may have occupied some space in the physical disk, right? So the same way on the index also, it occupies some space, and that if you keep on removing the records from the table, right, so that may creates the fragmentation over a period of time. To do the sync of that, what we may have to do, because it takes time, because if you in a like a larger system like a data warehousing kind of system, if you want to use that, it consumes more time. If there is a more fragmentation, it takes more time in reading the data, writing to it and all, right? For that reason we should always fine tune it, and for the better performance it is always recommended we use or we apply the index maintenance strategy onto it. Now two ways we can do that. How we can do is, the first kind is what I am explaining, which is reorganizing the indexes. How we can do, let us just see. There is a syntax for the reorganizing the index. The syntax is alter index, then the index name. It could be applied on a single column or applied on a multiple columns, on the table name or a view name. Okay, it can be applied without schema or with schema, in the form like this: database name dot schema name or schema name. Like I mean, usually we write like the database name dot schema name dot table name, like that we write, right? And maybe instead of that we can write like a schema name dot table name, like we used to write like stage dot batch or stage dot course, like that we write. So that is written with like this: schema name dot table name, like that, right? So that way you can this is the syntax for that. And then in that there are two options. The first option is to disable, the second option is organize. Now we will understand the usage of this afterwards. Just for now, understand like all of these two are the independent options available. So any of this option can be used interchangeably as per the requirement. Okay, if you want to disable the index, you use the disable keyword. If you want to reorganize the index, then you use the reorganize keyword. What is the purpose of reorganize? Is it defragments the index by physically removing the rows those are logically deleted from the table and merging the row groups. Okay. Now, what are the features of this reorganize index thing, right? It drops and recreates the indexes. Is it true? No. It doesn't require the indexes to be dropped or recreated. For that reason, the option is no for that. Meaning it doesn't require the indexes to be dropped and recreated. Okay, it doesn't require that. Second option, can we apply it online? Meaning like, do we have to take the database offline and then apply on it, or it can be applied online itself? Yes, it can be applied online. Okay. Then the third option is like the feature is can reset the fill factor value. Meaning like fill factor is a different concept, right? we just basically use for the like fragmentation purpose. So that is what it by default says, like no, it doesn't require that, right? We need not to reset the fill factor for that. Now updates the statistics, no, it doesn't require to update the statistics. Okay. The another point is recommended when fragmentation level of the index is, see, when the recommendation applies is when the fragmentation for in the index file, as I shown you, right? Like in the index, right? If you go to this tab, you will always find the fragmentation first thing. So that's where the first two tab, right? The total fragmentation and this thing, that's where you will find the percentage. So that percentage it is talking about here. Okay. When fragmentation level of the index is between 5 to 30%, in that case we should be using the reorganize. Why? Because it is a less number of it's a less fragmentation in the index file. For that reason it can be applied online itself, and it doesn't require the indexes to be dropped and recreated, right? For that purpose. Then resource consumption, less resource consumption is required in the case of reorganizing the indexes, right? Now just let's just see the syntax to that. We will be using the same learning DB for that, and then we will how to disable this index. Right now, when do you need to disable the index? In the case when you do not need those indexes to be in use, right? When you want to apply some operation on a particular database, when you want to revise data, when you want to like apply some data, or when you want to patch some data to a table, or various kind of scenarios may be there, in that case you may need this index to be made disable. So how can you do that? You can do that using the alter index all meaning all the indexes on stage dot batch table, and make them disable, right? That is the syntax. So let us just run this. Okay, it has thrown the warning. Now you will ask me why this warning is. Warning is applied because when you see the table stage.batch, now stage.batch has what? Let us just go and see here. Okay, stage.batch. Yeah, so stage.batch has what? When we made this stage.batch as when it was when we disable it, right? So what it does is, first of all, it disables the primary key of it, the batch ID column on which like the index is created, right? So itself it will disable that first thing. So for that reason, if you see like here, the batch ID itself is disabled. Now when it got disabled, the same time the foreign keys also would be disabled in that case on its own, so that no other like the covering index or any of the other dependent indexes were there. Automatically it disables everything, because we disabled the main table index only, right? For that reason it does so. If you want to do that for a particular thing, then you can apply as an index for a particular constraint, right? You can disable the particular constraint, and then you can work on the subsequent one. But when you apply the index on all of the index, right, for that reason it is applied and disabled all the indexes, whichever it was applied on this table, it has applied on this table, because we applied all here, keyword all as a keyword, right? So all the indexes which were there on the table, it got disabled here in a one go. Now if we want to reorganize the index, how can we do that? We need to run this syntax, alter index all meaning all the indexes, and stage dot batch reorganize. Now before we do this, because you did the disable of it, right, all of this, so we need to enable them, right? To do that, how can we do that? There is a syntax for that which we will need Let me just run it here. Okay, just for that, rebuild. Okay, so what it will do, for now I am doing this. Whenever you disable the index, to enable the indexes back, you may have to apply this command. Okay, so that it will become enabled again. And then I'm just removing for now, it is not required, but just I wanted to show you the usage of it. For that reason I have just added it. So what we need to do is we need to reorganize them. So let us just run this syntax. Okay, so it may not throw any error, because what may happen is if I will say disable and then if I try to say organize, it may not work. Why? Because it will expect it to be enabled in that case, right? And we made them disabled. So in the case of disable, this may not work, because the reorganize requires what? It doesn't allow them, it doesn't require this first condition. The second condition, it requires them to be online, correct? For that reason. Now let us just understand the second type of maintenance. How we can do that is rebuild of the indexes. Now the same syntax is there, only just up to here everything is same, even up to disable also is same, only just this keyword changes. Rebuild rebuilds what? One or all of the indexes. Now if there is a fragmentation more than 30%, usually this is the standard practice, is what as per the Microsoft documentation I'm just going through it. Okay, so I'm just mentioning according to that. Forgive me in case if I'm not adhering to the standards one, then but as per the documentation I'm going through it. So here, so the syntax remains same, only just that rebuild keyword changes, then the features of it. Now here the difference you may see, that drop and recreate is required. Why? Because it needs to drop the indexes and it will create the indexes. Because see, there is a small change in the particular index, then it is not advisable. Because say like if you have millions and millions of data in a table, so that many millions of records will be there in the index itself, so that maintenance activity will take up so much of your time, right? In a, like suppose if you are DBA, if you are administrator of the server, managing the maintenance activity at late in the evening or maybe late night, right? So in that case you may have to schedule the job and you have to put this activity for the maintenance. Now in that case, when this kind of fragmentation is there, you don't have to be available in right in front of the system. You can schedule a job and then you can go for the day. And then for that reason, like this drop and recreates index is applied here as yes. So dropping of index will be happening and then recreate. So recreate will do what? It will go and again reshuffle all those index keys, like the clustering index keys, right? The column store index or whichever index keys will be there. It will be ordered according to the clustered index applied onto the particular table, right? And in the right order and without any fragmentation, it will organize them in a sequential order, right? For that reason, it will be beneficial to drop all of those indexes and recreate them. For that reason, this option is there. Now online operation, it can be done online, but it is very time consuming and critical also. So usually we should take it offline only when the users are no longer working, because the operation itself will take so much of time, because say like millions of records are there, right? So for that many records it has to create the index, so this entire process will take more time, right? Ideally. So in that case option is available to make it online or offline, but recommended is offline mostly. Can reset the fill factor value? Yes, it can reset, meaning like you can keep the ratio to up to certain extent, how much disk space you want, how much space in the index file you want to be kept at the end of the each page, right? So that way the fill factor works in a great detail. If you want to go on, I will provide you the link in the video, so that you can refer to the Microsoft documentation to read further for the fill factor topic on this. Okay. Now update statistics. Update statistics also is the by default it is setting up yes here. Okay, so best way to use the statistics as yes, because it will reconfigure all the sequential data in the index file. So all the calculation wise, or if the numbers are come up in the right order, right, for that purpose. Now then the recommended when the fragmentation level of the index is means greater than 30%, right, as we just saw here, like greater than 30% whenever is there, then we apply this rebuild option. And the resource consumption is more resource consumption, right? You see, it requires more resource while performing this maintenance activity. So in operational work hours, we should avoid this activity. Okay, so let us just run all three of this option together. Yeah, it will work here, because here the same syntax, like the disable, you disable the like this particular index, and then you do the rebuild of it, single index rebuild with no option specification here. Okay, there are multiple other options that you can apply with the rebuild also, which I am not explaining in a great detail here, but I will provide the documentation link in the video, so you can refer to that documentation, Microsoft documentation, and go through it. All right, so let's just run this. Okay, cannot find the PK course. Let me see why I did not find it. It may not have the PK course here, it may have the PK batch ID. Yeah, so my bad, let me rerun this. Cannot find index PK batch ID. What was the index we created on batch? Primary key was given some different name. Actually, this is the name that we gave to it. Or not, primary key itself was not there. Only the IX batch build was given there. So let us just give this name to it instead of that, and then we run this again. Okay, so now it has cleared. All right, that's it for the session, and happy learning. Thank you.